right, let me zoom in. All right, so this is a handout that we did today all about motion. The first ones are about this distance time graph, and we studied what each of these lines mean. We should know that the steeper the line, the faster it's going. So for example, if I had this graph right here and I had this line, line 1, this line 2, and this line 3, line 1 is going faster because it's closer to the y-axis, and line 3 is going the slowest. So at rest would have been line E because the distance is not changing. Fast, constant, steady speed, the fastest line is going to be B because it's the steepest line. Slow, constant speed, that's going to be C. It's not going to be A because A is a little bit steeper, so it's moving faster than C. So slow, constant speed was C. Acceleration is always a curve, so that's going to be D. And then moderate, wait, let me focus a little bit because it keeps jumping. Okay, there we go. And then moderate constant speed is going to be A. So B is the fastest, then A, and then C. Okay, this line is steeper than A, and A is steeper than C, which is right here. The next part of our handout was calculating speed from a graph. The first segment is from 0 to 2 minutes. So I already know that my time is 2, because if I start at 0 and I go to 2, that's only 2 minutes. The next thing that I have to find is my distance. Well, 0 to 2 is right here. So this is a segment that I'm calculating rise over run for. So if my time is 2, my distance, I started at 0 and I went all the way to 30. My distance is 30. And my formula for speed is d over t. Therefore, speed is equal to 30 divided by 2. And we should have gotten 15. And my final answer was 15 meters per minute. If you did not put the units, it is okay. But I would like for you to include the units. The next segment that it's asking about is from 4 and 6 minutes. 4 minutes is right here. And 6 minutes is up to this line, so I'm focusing on this line segment. From 4 to 6 minutes is 2 minutes again, so t is equal to 2. My distance is different. When I was already at 4 minutes, I was at 30 meters. When I got to 6 minutes, my distance was 60. My distance was not 60 overall because I already started at 30. So my distance was equal to 60 minus 30. So my formula again is d over t. My distance is 30 and my time is 2. My final answer is 15 meters per minute. And then for number 8, the average speed. The formula for average speed is my total distance over the total time. My total distance was 60. All the way right here, and my total time was 6, so my final answer was 10 meters per minute. So do you guys have any questions before I move forward? Okay. For numbers 9 through 12, an approaching storm is moving east 60 kilometers every 30 minutes. What will the storm's speed be in kilometers per hour? I already know I need to change my units from minutes to hours. So speed is equal to d over t. My distance is 60, but my time is not 30. 30 minutes is 1/2 of an hour. So if you didn't know that, you could have did 30 divided by 60 and got 1/2. I'm going to divide by 0.5, and my final answer was 120 kilometers per hour. Alright, so now we're going to continue with problem 10. A train is traveling 100 kilometers, that's my distance, in 30 minutes, that's my time. What was the train speed in kilometers per hour? That's what we had to focus on. So I'm looking for speed again. Speed equals d over t. My distance is 100. But my time is not 30 minutes because it wants it in hours. So my time is actually going to be 0.5, which is half an hour. Okay? So S is equal to 100 divided by 0.5, which is equal to 200 kilometers per hour. All right, next is number 11. Melissa leaves math class at 9:10 and arrives at her science class at 9:40. It is 160 feet from the math classroom to the science classroom. What is the average speed? Average speed is total distance over total time, just like we did in number 8. We were having trouble calculating her time, but if I told you you had to run from 9:10 to 9:40, everyone got that you would have been running for 30 minutes. So speed is equal to distance over time. The distance is going to be 160, and the time is going to be 30. Right? So 160 divided by 30 was 5.33, repeating. An ant crawls onto a ruler at 10 centimeters. He crawled on already at 10 centimeters. Then he went to 30 centimeters, and it took him 4 seconds. My distance was not 40 because he crawled on at 30. So that's like if I had a ruler, and he crawled on here, and then he went to here. This is not his distance. He didn't crawl the whole ruler. So S is equal to D over T. S is equal to, that's going to be 10 to 30, so that's going to be 20 divided by 4, sorry. And 20 divided by 4 is 5 centimeters per second. My little screen is in the way. Okay, we'll flip over to the back. Okay, 13 says, what is the reference point? Well, I'm starting at 0, so 0 meters. What is the total distance? The object went from 0 all the way to 10. Even though it took a break, it still went to 10, so 10 meters. The displacement is going to be still 10 because, hold on, let me refocus, sorry. The displacement is still going to be 10 because it never returned back to the starting position. At what time did the object begin to be at rest? It was at rest from here to here, and that started at 3 seconds. We're looking for time, guys, not position yet. How long was it at rest? It was at rest from 3 to 6, so that is going to be 3 seconds. At what position did it stop? It stopped right here at 6 meters and 3 seconds, so the position was 6. How much time did it take the object to get to the other end after it was at rest? All right, so it was at rest from 6, and then it got to the end at 10. So 6 to 10 is going to be 4 seconds. At what part of the trip did it travel the fastest? That's going to be 0 to 3. That's the steepest line. And the average speed, the total distance is 10. The total time was 10. So the average speed was 1 meter per second. All right. Which segment shows slowing down? This is a speed time graph, so you should know that this is accelerating. This is constant speed because the speed stays at 50. This is slowing down, speeding back up, and then slowing down to a stop because the speed becomes 0. So slowing down and stopping was E to F. Slowing down to 20. So I'm just going to look across 20 and see when did I hit that mark. Well, it slowed down to 20 from C to D. Traveling at a constant speed, I'm looking for a horizontal line, that's B to C. Speeding up from 20, here's 20. Speeding up to 30, that is segment D to E. Accelerates to 50 miles per hour, that's going to be 0 to 50, so that is segment A to B. All right, last one. In which section is the car going at a constant speed? This is speed versus time. This is accelerating. This is constant speed. Negative acceleration or acceleration. This is acceleration as well. So constant speed was B. How fast was it going at B? It was going 12 miles per hour. Which section is the car accelerating the fastest? That's going to be the steepest line, so that is going to be A. How long does it stay at constant speed? 4 to 6 to 8 to one more, which is actually 9. So that's 5, that's 6, 7, 8, 9. So from 4 to 9 is actually 5 seconds. How far does it travel in section A? So this is where I showed you guys the triangle, where I told you to use your triangle. How far is a distance? So if I cover up D, I need to multiply my speed times my time. So for section A, right here, my speed is 12, and my time is 4. So 12 times 4 is equal to 48 miles, And then I'm looking for how many miles was the car in negative acceleration. That is going to be this line right here, line C. And I was at 12, and I went down to 6. That's 6 right there. Okay, so 12 to 6 is a change in 6 miles per hour. That's my speed. And then my time from 9 to 10 to 11. Okay, so how I got that was right here, 9 to 11. And that was 2 hours. So 6 divided by 2, actually, I'm sorry, 6 times 2 is 12 meters. That's how you find how many miles, because that is also a distance. So I needed to multiply my speed times my time.